Velocity time graph. So as we discussed earlier, velocity time graph, what do they give us? Velocity time. So when we take gradient, that gives us the acceleration, and when we talk about the area, that gives us the displacement or distance depending on the shape and criteria. So, and looking at the first graph, if I see this is a horizontal line, its gradient is 0, and I can also read from the vertical axis that the speed is 0, so the object is at rest, and area under this straight line is nothing. That means no distance is covered. In the second graph, again gradient is 0, and the gradient gives you the acceleration 0, it is moving at constant velocity, and the distance covered is the area under the graph, which is height times base or velocity times its time. In the third section, if we talk about the area that makes a trapezoid, and area under the graph will give you the distance. Looking at the gradient, it is a constant gradient. That means the gradient gives you the acceleration, that is a constant acceleration. Speed is increasing at a constant rate. Example question. The figure shows a velocity time graph illustrating the motion of a cyclist moving along a straight road for 12 seconds. So this complete as 12 seconds. For the first 8 seconds, she moves at a constant rate of 6. For first 8, constant rate of 6. She then decelerates at a constant rate, stopping after 4 seconds. She must have applied the brakes or stopped pedaling. So she comes at rest at 12 in the next 4 seconds. A part, find the displacement from the starting point. Let me clear this. So find the displacement from the starting point of the cyclist after 12-second period. So we know new displacement time, velocity time, acceleration time. So when we are talking about the displacement, I have to find the area. So area of this trapezium is 1 by 2. Sum of parallel sides, that is 6, plus 8 plus 12 times this height, that is 6. 1 times 3 times 8 until 20, 3 is 60 meters. B part, work out the rate at which the cyclist decelerates. Gradient gives you the acceleration. So if I'm talking about this gradient, that is y2 minus y1 over x2 minus x1. Minus 6 by 4 is negative 1.5. This is the acceleration. And acceleration and deceleration are opposites of each other. So deceleration is 1.5 meters per second square. Clear? Another example, a particle moves along a straight line. The particle accelerates uniformly, straight line, from the rest to a velocity of 8 meters per second. So it continues straight from 8. Okay, that is actually the part of solution. So let's read and then construct. So uniform means straight line from rest at 0 to reach a speed of 8 meters per second. So that's 8 in t seconds. So on x-axis, we label that capital T. The particle then travels at a constant velocity of 8 meters per second, constant velocity, no gradient, straight line for 5 t seconds. So if we've considered this unit as t, making a length which is 5 times longer than this, either we label it 6t or you mention that as done in the example. The particle then decelerates uniformly to rest in further 40 seconds. So when it decelerates, whatever the time is before that part, this becomes the new time, that is 60 plus 40. Sketch done. B part says given that the total displacement of the particle is 600. Now again we are talking about velocity time graph, displacement time, velocity time, acceleration time. area of velocity time graph actually gives you the displacement. Displacement is already given. So how we find the time is equating the area of this shape to 600. So that would be 1 by 2 sum of parallel sides. This length here is 5t. The length at the bottom is 6t plus 40. And the height is 8. And equate that to 600. So once we solve for this, 600 by 4 is 150 on right side, and 6 and 5 is 11t. Taking this 40 on the other side, 11t is equals to 110 and t is equals to 10. So given that displacement, value of t is 10 seconds. Any confusion? Exercise 2b, question number 1. The diagram shows the speed time graph of the motion of an athlete running along a straight track. For first 4 seconds, he accelerates uniformly from rest to velocity of 9 meters per second. First 4 seconds, velocity 9. This velocity is then maintained for further 8 seconds. Further 8 seconds, straight line maintained velocity. Find the rate at which the athlete accelerates. Again, velocity time graph, displacement time, velocity time, acceleration time. From velocity to acceleration, that's a gradient. So the rate at which the athlete accelerates is this gradient, that is rise over run, 9 by 4. And the units are meters per second square. B part. The displacement from the starting point of the athlete after 12 seconds. Displacement, so that's an area. 1 by 2, sum of parallel sides, this is 8, plus 12 times height, that is 9. 8 and 12 is 20 by 2, 10 into 9 is 90 meters. Question number 2. A car is moving along a straight road when t is equals to 0. The car passes, the demand is sketch. So we are reading this and converting it into a graph. When t is equals to 0, this is my point. The car passes point A with velocity 10 meters per second. And the velocity is maintained until 30 seconds. The driver then applies the brakes and the car decelerates uniformly, comes to rest at point B, t is equals to 42. Sketch a velocity time graph to illustrate the motion of the car. Okay, when the car passes at time 0, it passes with velocity 10 meters per second. So we are somewhere here. 10 meters per second, velocity, time in seconds, velocity in meters per second. For first 30 seconds, so we draw a straight line for the first 30 seconds. And then it comes to rest at 42. That's a further 12 seconds. So this is 42. Sketch done. Find the distance. Distance is the area. So 1 by 2, sum of parallel sides times height. And that is 30 plus 42. 72 by 2 is 36. Times 10 is 360. Question number 3. Let's pace up. The diagram shows velocity time graph of the motion of cyclist riding along the straight road. She accelerates uniformly from 8 to 20 in 20 seconds. Uniforms to 8 in 20 seconds. She then travels at a constant velocity of 8 meters per second for 40 seconds. So these are the next 40 seconds. She then decelerates uniformly in the last 15 seconds. A part requires the acceleration of cyclists in the first 20 seconds. So that is rise over run 8 by 20. 8 by 20 is 2 by 5 or 0.4 meters per second square. B part. the deceleration of cyclist, again gradient of this section will give us the acceleration. So gradient is basically minus 8 by 15. So deceleration would be positive 8 by 15. C part. The displacement from the starting and the units, sorry, are meters per second square. C part. The displacement from the starting point of the cyclist after 75 seconds. Area 1 by 2. Sum of parallel sides from 20 to 60 is 40 plus 75 times height. That is 40 plus 75 times 8 is 460 meters.